Steier from Munro and Associates and John Scott Thomas from our sister company TechInsights are going to talk about the infotainment system, which is a guy who's pretty intimately familiar with a car. It's my one peeve about the Chevy Volt. I like almost everything else about it, and I'm not really a GM guy. But the design and the interface of the center stack leaves a lot to be desired. So with that, take it away, Al.
Hey, I thought we weren't supposed to bash anybody in this presentation there, Brian.
I'm not bashing anybody, just a certain design.
Welcome, everybody. I'm Al Steier with Munro and Associates. I was the one that did the 3-day teardown back in Detroit, Michigan. And we got John here with me. We're going to discuss the infotainment section today, or basically anything you touch, feel, hear within the car. We're going to talk about the body control module and what it's doing in the vehicle. We're going to talk about the communications interface module, which is another module that was located up in the vehicle. And then we're going to get into the center stack section, and then also the instrument cluster. So we're going to start with this communications interface module. Now basically this module was stuffed up under the passenger side, and it kind of mounts in an upward direction, and then the connectors are up on it, and then a single cam lock, and it was pretty simple to get in and out. It's housed in an aluminum housing, and it's got a metal shield on the backside. So the thing's got EMI protection, so that's why it's in the metal housings, because you do have the communications going on in here. You got the Bluetooth, and any of those other things. It's part of the OnStar. You got the LAN communications, and then you also have a video line that runs out of that, if I'm not mistaken, right, John?
What we see on here, on this particular communications board, is a suspension flash. That's what holds most of the firmware responsible for the communications of the car. Thanks, Al. And I'll just got a handy green laser pointer here. That's over here. Then Freescale DRAM memory controller. Zentel is a Taiwanese company, and it's a fairly generic SDRAM product. And up here, what you can see is a small Bluetooth antenna, this little blue rectangle, and a Bluetooth transceiver made by LG, Korean company. And that's what's responsible for the Bluetooth connectivity between your smartphone and the vehicle. So the path here for car manufacturers is to integrate the electronics with the internet, with your smartphone, as time goes on, so that you have all the entertainment that you would normally associate with your portable devices. In a sense, it's a large portable device itself. So one of the things I really enjoyed about looking at this part of the vehicle is that I got to work with some of the systems guys at our company. And these guys are really good at taking a look at the kind of software that you find on portable devices. And I went up to them and I said, you know, I'd love to look at all of it, what controls the battery and so on, but let's pick something that maybe is interesting to you. And so they selected the suspension flash, which holds the communications software. And I'm more of a circuit guy, but I always find this kind of amazing. They pop the board, or the part off of the board, and put it in a special device that can extract the firmware, and within a couple of hours, they're looking at something like this. And this is a flow chart for the firmware. And they can go in there. These guys are really good. They can pick it apart and tell us how the system is operating and the kinds of algorithms that are being executed. And you know, for the purpose of this talk, I was really more interested in who are the people that are the companies that are involved in the production of the firmware that we see in the infotainment system. And it's relatively simple once you convert it into standard ASCII characters. Within a couple of minutes, they went through it and they found out that the operating system on the communications board is QNX. You can see the information that's coming into the communications board. There are variables that are defined. You can see the battery state of charge in there. You can see you know, how much fuel there is in the vehicle. The tire pressure variables are stored up there. All sorts of interesting information. And obviously, from this point, once we've identified the variables, to going in and looking at the algorithms is a complex but very doable step. So from the presentation this morning about internet security and so on, you will see this thing is linked up to the internet and through Bluetooth. And it took our guys literally a couple of hours to get to this level where they're ready to go in and start doing things and perhaps hacking the vehicle. Now, you know, it's not clear that that's an easy process to do, and we don't really understand what kinds of encryption protection there is from changing the software. But I suspect that there are all sorts of security issues in vehicles in general, not just the Chevy Volt, that will have to be addressed. So the guys back in the systems group went back, and I just said, give me a high-level view of what's going on in there. The first thing they saw was that there's a QNX operating system. The board support package is done by Mikroelektronik, if I'm saying that properly. It's a German company, and they specialize in ruggedized board design and support. Freescale has some firmware sitting on board. Open Mobile Alliance, there's an update manager is there. WiMAX Forum, these are all open standards and open groups, generally speaking. And then finally, the one I found the most interesting was this Funamball, if I'm saying that properly. And what it is open source code for mobile cloud access and synchronization. And it looks as though the entertainment system can be connected to the cloud through the Wi-Fi. You can do all sorts of interesting things. You can push email with this particular open source as well. So Chevrolet MyLink, if you follow cars and you're into GM products, MyLink is something they've been talking about. Originally, I had heard that it was coming out last fall. I believe that's been pushed out to spring of 2012. One of our questions was, is MyLink on the system in some sort of prenatal state? What MyLink does is it allows you to turn your car into a kind of a smartphone and access the internet. It has the capability, or will have the capability, to connect with Pandora to get internet radio, voice recognition from Nuance, which is, if you follow Apple products, it's Siri. Nuance does that type of voice recognition. OnStar, of course, GM product. They're all in MyLink. And from looking through here, we don't think MyLink is really present in this particular vehicle, but everything is there for it to be turned on in a while. So the basics are ready to go. Probably if you went out and bought one now or in the next couple of months, they will turn it on. What I noticed when we were looking at the dashboard of the Chevy Volt is there's a large similarity to a Porsche 911. I went out into my driveway and got in my car, and sure enough, yeah, that really does look like the thing we're looking at work. Not quite. I don't have a Porsche 911, actually. But I did see this on the internet, so it's got to be true, right? Actually, what this is some folks up in Ottawa, which is where we do our analysis, took a Porsche 911, and it happens to be QNX. I was talking to a gentleman who actually works there, and they had done the QNX operating system for the Porsche 911. And he said it was the saddest thing that I've seen. I got to take it out for a drive, and then they took it into the shop, and they took down a Porsche, doing much the same thing we're doing with the Chevy Volt. But what I found interesting was that the display boards you see on the Porsche 911 are very similar to the Chevy Volt. And that may in part be due to the fact that there's QNX on board, allowing this type of configuration. So if you value infotainment, maybe all cars are going to become the same or evolve to a more standard look. What we will see as time goes on.
So anyways, we'll move on to the body control module. Basically, the body control module resided up under the left side, under the right by your left front kick panel. The previous module, the communication interface module, you've seen it had shielding. It was an aluminum housing, had a shield that was bolted onto or snapped onto the outside of it. Now we get to the body controller. We're not so worried about the electronics in this case. As you can see, it's just housed in a plastic case. This is one of the trends I've seen a lot in a lot of the automotive is they started to go to plastic modules. The PCB board just slides in, and then when I pull it out, I gave it to John, and he left it in Canada or something. But anyways, there, you can see down there in the bottom left a picture of it and a big old header on it. It did have a number of connectors, and they are all color-coded on the bottom of it. And so it's kind of an assembly aid at the same time. The module just slid up into a bracket up inside, and a little cam lock or a screw held it in, a single fastener. And if we go to the next slide, we'll look at some of the inputs. So, what does a body controller do? When you open the door, it senses the door ajar. You hit the lock button, it senses it. You turn on the lights, you dim the lights. You can see you got battery voltages coming in. It knows the headlamp position, the LED indicators. So it pretty much drives everything inside the vehicle that you're going to see when you're operating it. And we go to the next slide. You can see we're on connector 3 here, even the vehicle theft alarm. There were 7 connectors total on here. I forget what the total pin counts were, but there was quite a few of them. The exterior lighting again, windshield washer wiper, the fluid level switches, Voltages, you got accessory, you got ignition, you got run, you got crank. All those are inputs to this module, so it knows what to do and when to do it. Daytime running lights, tail lamps, lift gates. So its inputs and outputs are all controlling these various functions in the body control module. The next one.
Yep.
So now we're looking inside the car. This is basically kind of a view of the dash that we captured. So we're going to be starting to go into the instrument cluster and then the center stack section of the vehicle.
All right.
So as you can see here, you got the touchscreen display on the right in the middle of the center stack. You got an LCD display in the instrument cluster itself. Then below the center stack, you have a touchscreen panel that's sitting down there, and we'll pick that up here in a second and look at it. And it has a number of inputs that are in there that are controlling either the LCD display or they may be distributed over into the instrument cluster panel as well. Now, typically what you'll see is the instrument cluster on the left, that's going to tell you the state of the vehicle. You know, is your engine oil need to be changed, how much fuel you have left, how fast you're going. The center stack is more the infotainment side, your heat controls. If you got your radio on, the volumes, and all those various settings. So the left side is more vehicle specific. What is the vehicle doing, and where is it at this point? The right side is more your convenience, your luxuries, if you want to call it that. If you like listening to the radio and all that, I just listen to AM radio on my way into work usually. So, but anyways, we'll go to the next one.
I just want to say one thing here. Well, I got to drive one of these a week ago at the dealership back in Ottawa. And this little guy on the left here is a pedestrian warning. And when you turn the vehicle on, if you're used to driving a gas engine, so anybody here have a Chevy Volt or an electric car? Or has anyone tried driving one of these? It's quite cool. They're actually totally silent, which is a very unusual experience when you get in a car and turn it on. And it does all this beeping and blooping to let you know that it's alive. But when you start driving it, especially at low speeds, it's basically silent. So what they have to do is install a pedestrian warning. It's just a button that you press on the left-hand control stick, and it gives off a little bloop sound, and that warns people that the car is coming because they have no auditory warning. So when I was driving it, it's totally silent, and as you get up to speed on a highway, you hear the whooshing sound. And I think the talk about the Tesla yesterday talked about this experience of driving a very quiet car. And it's a lot of fun. So we'll go on from there.
Yeah, with that in mind, I know I've seen a lot of things with Nishta and the safety side of it. And what are they going to do with electric vehicles? Because they are quiet, you don't want to run over a handicapped person, someone that's, is hard of hearing. And are they going to standardize some sort of sound that they're going to make? But when you start thinking about it, what's that going to do? It's going to take away from the power usage as well. So as we look at, now we're going to look at the instrument cluster. So basically, we got the speed up there. So the speedometer, what is the vehicle speed? That's going to be coming from the inverter converter. Majority of all the inputs to the instrument cluster are all coming over the GM LAN or the bus system that they use. So you got your fuel system, the fuel tank. The engine control module needs to know how much fuel it's got in the vehicle. It's going to bus the information over to the cluster, and it's going to display it to the driver. There's a little carousel of icons you can see down on the bottom. You can set your trip meter and how far, so you know how far you went on trip A, trip B, etc. But those are more customer programmable features, and you would have to go probably through the touch screen to get to access those. If we go to the next one. So now we're looking at, it'll give you some tire pressure indicators. So if you have a low tire, basically this is also going to be a bus information signal sent to the cluster. You're going to have some sort of module sitting in the vehicle for tire pressure monitoring. Each of the tires are going to RF signal to the module what their pressure is. That then is going, when it sees it's low, it's going to actually send it back up to the instrument cluster to let the driver know that he's got a low tire. Some of the other features that you can have set up on there, how your efficiency gauge, you'll show that up. So this is going to be looking at the inverter converter, and it's going to be looking at the brake pedal. So when you're braking, it knows how your brake pedal actually is more or less disconnected from the master cylinder on the vehicle in the electric vehicles. So when you press down on that brake, basically it's an input. From there, the inverter converter is first going to take over and start doing the regenerative braking. And that's where that signal is going to show up, where that ball is. If you're braking too hard, it's going to drop down here. But what happens when you brake too hard is it starts to actually engage the hydraulic brakes. So there's a transition from regenerative braking to actual hydraulic braking. So there is still a link there. but it still has to indicate that. So that way it'll let the driver know, hey, don't try slamming on the brakes so hard. You know how to slow the vehicle down. So they're trying to take advantage of that regenerative braking in this case to recharge the batteries.
I'll just throw in here, so there's kind of a game that happens as the driver. You try to keep that ball in the center, and it turns green and spins.
Sounds like a driver distraction.
It's a little bit of a video game, and it's kind of, at first I thought this has got to be a gimmick, and this is going to distract me, and I'm going to crash the car.
You should put it on the passenger side.
Pardon me?
Put it on the passenger side for the navigator.
So. Entertain the kids or something, right? But I actually did find it quite easy to drive, and it's a relatively good feedback. And what's interesting about this is it actually makes the driver, the carbon processor, if you will, part of the feedback loop. And you do get kind of addicted to trying to keep that ball centered. On the flip side, if you're trying to accelerate too hard, the inverter will be driving a lot of current into the electrical motors, and you'll be dissipating unnecessary current. So it's relatively easy and comfortable to keep that ball centered. And as we'll see on some of the other dashboard displays, GM's obviously made put a lot of effort into this idea that you should become aware of the power that you're using and take steps to try to conserve it. So a lot of the center stack displays, as we will shortly see, are also focused on this game of trying not to use power unnecessarily.
Okay, so with that in mind, we're going to look at the instrument cluster here and where it's at and so on. So this is actually behind the steering wheel. You got this bezel that covers it over. This wraps around the steering column itself. This vehicle does have a steering wheel, the adjustable steering wheel. So you can see the closeout's actually part of the bezel itself. It's kind of neat. So basically, they put this in and then they just snap it in. When you're in an assembly plant back there in Detroit, you try to reduce the number of operators that you need and the number of parts coming in on the line. So it is two pieces. It does snap apart here. But this piece, a lot of times, could be 3 to 4 parts that come into the assembly line. So now you integrate them. You have them done by a Tier 1, Tier 2 supplier. Helps reduce some of the assembly costs associated with the vehicle. Then as we dig down into it, so basically this goes into the back of the vehicle. There was only a couple of connectors. Had 4 screws holding it on. You have your display here. The case, again, just snaps together. No screws, no fasteners required for it. And then there was the cluster itself, the module you see down in the bottom right sits there, and then you have your LCD board sitting here behind it that displays out through the screen itself. And if we go to the next one, I think we'll let John discuss the board itself that we found in there.
So the board, the instrument cluster board, is a fairly standard design. You can see some connectors, inputs, and outputs here. Freescale has the main display controller. The part numbers for all of the ICs that we've extracted and identified are available on the website. So if you want to get more information about the integrated circuits, you can go to the Design for Innovation website or UBM TechInsights or maybe Munro. I think you'll be posting those up. So there's a lot of good information on the data sheets if integrated circuits are your thing. The expansion flash down here holds the firmware for the instrument cluster. And one of the things the guys pointed out to me when they took this board out was all the test and debug and control interfaces that had been desoldered and were probably used during the manufacturing and design process and are no longer populated down at the bottom. And now, so I'll kick us off, and you want to take over? Or
yep.
I'll talk
about. So this is the center stack area. Now we're getting into the center stack display.
Okay. So now you're looking at what you would see in the center stack display. That's the one in the middle of the vehicle that Brian's not too gung-ho on. And we are now it can do a number of different things. It's a 7-inch LCD. I believe it's Toshiba that makes the LCD touchscreen. And by touching these various buttons, you can get into different modes. When you press that leaf button, a mechanical button on the center stack, you get this display coming on. And the leaf mode is again, this feedback about, maybe, Al, you can show us there.
We'll put it up on the video camera here in a second when we get through all these.
And what the leaf mode is supposed to do is to make you aware of how you're using your energy and how the vehicle is using the energy. So the power flow display has this nice little icon of the battery and then how power is moving between the various components. That's the gas engine up there. That's the inverter, the central brain, if you were at the talk yesterday, that takes power from the battery and from the gas engine and transmits it to the wheels. And when you go into battery mode or gas mode or regenerative braking mode, these little signals along virtual wires start flashing to show you how the power is moving. So it's relatively easy to read while you're driving. And again, you're into this little game of trying to use your regenerative braking when possible and not use your gas engine.
All right, so then this is more looking at the leaf mode again. Again, this is a touchscreen display. Gives the operator various options. So in this case, it's just showing the charge mode. Do you want to do it right now? Do you want to delay it? Or you have another option. Do you want to set it when the electrical rates are lower? You know, I'm sure everybody's aware your electrical rates during the daytime are a little higher than they are in the evening time. So if you're working midnight shift and you're going to leave for work at 11 at night, you might not want to charge your vehicle from 10 in the morning till 3 in the afternoon. You might want to wait till 4 or 5 and have it start charging. But it does give you the option to program it to charge when you want it to charge, as opposed to just charging it immediately, just using the 15 cents a kilowatt hour versus an 11 cents or whatever the case is. So it's another way of saving coupons, kind of like my wife says, use the coupons all the time. So this is another way of saving a little extra money. So in the next one, this one's what? We're looking at the energy info. So, John, you want to discuss this one? Or?
Sure. This is basically a summary table, a statistical table that provides you information about your driving habits. And I have a nice little button down here, efficiency tips, basically how to drive better from an energy perspective. And it just shows you everything's zeroed right now, but how many gallons of gas you've used, how much battery power you're using versus gas energy. And you can collect it for specific trips or the lifetime of the vehicle, and it's encouraging you, again, to use as much battery juice as possible and as little gasoline as possible. All right. So this is an interesting little feature that they have. So if you have a smartphone and OnStar system, you can connect to the vehicle through your smartphone, and this allows you, from a distance, to monitor and control the activities of the vehicle. So, for example, if you wanted, it's parked in a warm parking lot and you're coming back to it, you're going to be there in 5 minutes, you might want to turn on the air conditioning. Or perhaps you want to charge your battery when you're out in California on a trip and you want to have a nice charged up car back home when you get back home. So you can do things like that. Using the OnStar system, and if you saw the talk this morning, this sets up the interesting hacking opportunity where, people who are clever at these things might be able to take your car over using their cell phone. So, given the fact that we can get into various parts of the firmware quite easily, this sets up a very interesting scenario in the future for the security of this type of vehicle and this type of remote access that you can have. So we'll go to the next slide.
All right, so now we're going to look at what makes up this center stack. Just make sure where we're at here. So basically it sits in the center of the vehicle there, right between the driver and passenger side. For the most part, there's not a whole, it's real easy to pull these things apart, if you just got to be a little bit bold. But if you look at the center stack in the vehicle, it's basically sitting in there looking like this. First thing you do is you just pop this out, snaps together. More and more of these vehicles today are starting to look more like Lego blocks, for assembly. You get rid of the fasteners. Fasteners are one of the highest quality issues in any assembly operation, so you always want to try to eliminate them. And they've done a really good job of that, except they did use 2 down here on the bottom of it. But once you pop this out, then you can take this one and then take these 2 screws, and the whole thing just pops out, and you just disconnect a few electrical connections, and you have it sitting in your hand. Yep, next slide. So now we're going to kind of look at, with the inputs, there's a number of different connectors in there. And actually what I want to do is let's switch over to the cam so everybody can see what's going on in here, because we did find something interesting. Now, one of the things that typically happens on your touch panels back in here, you'll have a circuit board, and then on it you're going to have little zigzag traces. They'll be separated, and then another set of zigzag traces. And then the switch is going to have a carbon pad on it, and when you hit the button, it actually connects those 2 zigzag traces. What we found on this board is there wasn't any of that. But what it has 2 ribbons that come up in from under the touch panels inside of here. So you got 2 little flex circuits that come up in here. Now, I know Brian was mentioning some concerns with this. whether it's new technology or a little bit different direction and change from what you typically see in control strategies. But it is a little more unique than from what you typically would see in an automotive center stack or button control system. And then again, you got the LCD, the touch screen that sets in here. Again, you have the ribbons connecting the interfaces. So usually these are, they used to be all hardwired and you just have, big plastic connectors to connect everything. But they're starting to go more to the flat cable, and then you just, plug them right into the circuit boards.
Center stack video PCB. Just a couple of things to add in here. Lots of sophisticated electronics. What you're starting to see in the infotainment systems compared to the electronics we saw yesterday and the day before, where basically all the microcontrollers were freescale, is a transition to a more global type of inclusion pattern. You see Sony here and Renaissance both have components on this printed circuit board. You can see a couple of other large parts. Look at the blue protective coating on there as well. So they often put that on these. I'm not sure why, because it's on the interior of the vehicle, so it's not really in a harsh environment, but it wasn't uncommon to find that. And I think that's really all I have to say about this board.
Okay. So now this is the one that sits right behind that control panel there. And what I was talking about, when you usually see the little traces, you don't see those traces on this board. But you do have a couple of little hard switches, but other than that, it's just a bunch of traces on here. You had the ribbons coming over, interfacing on the back side of this board. And what'd you find on that? Is there anything interesting in there?
So this part of the board, that slot in the middle is for the DVD or CDs, and it slides through there. There's a couple of things that are interesting. You've got an 8-bit microcontroller, fairly small, that we didn't identify the manufacturer of. We can by removing the packaging material and taking a closer look. We've got two Cypress PSOCs, programmable system on chips. And from looking at the data sheet, our best guess is that these things are used for the touch screens. They seem to be oriented towards touch screen measurement and control. Might be more going on. Why there are two, because only one of the screens is a touch screen, we don't know. Down below, that's just a little buzzer, that cylinder, and it makes a sort of a beeping noise whenever you press a button. They talk about it being a haptic control board. Haptic is just a fancy word for it has bumps, so you can feel where the buttons are. And every time you press, so you see this in a lot of vehicles, you press the button, it makes a little beeping sound, and the beeps can change tone as you move around the board. Let's go to the next slide. Okay, so to summarize, I will summarize from the perspective of an electronics guy. What we saw in terms of integrated circuits was a large variety in the infotainment system. It's not just freescale, and the reason I say that is it was just basically freescale in the power electronics and the battery control. We're seeing Sony, Renaissance, Cypress, Spansion, Zentel, Infineon does all the body control electronics, lots of low-side drivers and things like that to open your power windows. Inside the firmware, again, a wide variety of companies and firms and open source organizations are involved. QNX, Microelectronic, Freescale, OMA, Funamball. And I think the point here that I'd like to make from the electronic perspective is that GM has taken a real global village approach to the way this car has been built. Lots of different organizations have been involved, both in the electronics and in the module manufacturing. If you remember from yesterday, at the module level, you had Hitachi, TDK, Lear, making different parts of the power electronics. And so this is a very wide approach to the manufacture of the vehicle. And if you were at the talk about Tesla yesterday, the opening talk, there's an interesting comment made that they're trying to insource as much of the design and manufacturing as possible. It will be very interesting as time goes on to see which approach is more efficient in the marketplace. GM obviously has selected a very outsource-oriented program.
And with that being said, you think about it, just in automotive in general, the big three, they do typically do a lot of outsourcing in general areas, where the Tesla is more of a unique startup and they were trying to keep it all internal. One of the things GM is doing with these new hybrids as they're coming out, like the electric motors, currently they're purchasing them. But in the future, they're going to start making them because that's going to be their core competency. If these electric vehicles really take off and get into the market, you're going to start seeing these guys pulling this outsourcing in-house to maintain that cost advantage and maintain those profits from it, as opposed to giving it to their suppliers. So it is a very diverse conglomeration of global suppliers, not just U.S., not just Asian, but you mentioned we had some German manufacturers in there.
Right.
We got LG Chem. I'm sure there's some Asian, and there's probably even some Chinese manufacturers in a lot of the products that we see within here.
Even Canadian, Kunix.
Oh, you even got a Canadian in here. Oh, man. So with that, we kind of wrapping it up here. If anybody has any questions, answers. Brian, did you want us to run it, or you want to?
And please feel free to come up and look at the battery pack of the vehicle, which is right over there. You can. I don't think you're allowed to go in it, but you can certainly check it all out. And
if you have questions, we have a live microphone right there, and please speak your question in the microphone so the crowd can hear it. Pretty please.
So you guys were talking about insourcing and outsourcing. All this electronics, mostly on touchscreen and infotainment, do you guys believe they were developed in-house or outsourced as well?
Like the touch screens and all those would be purchase components from an OEM perspective.
But the board design and all the electronics, the software, was that outsourced like a consulting company, or you believe you guys did it internally?
It depends on which module and where you're at in the vehicle. Like on the battery pack, all those modules that are sitting on that, those are LG, and those are proprietary to LG. You get to the body control module, now that is a GM component, and they're going to design that one, because that's going to maintain all the interfaces. There's a lot of interfaces with their components in that case. The engine controller, all the OEMs make their own engine controllers. They'll design them, and they'll have direct influence over them. So you get in the infotainment, that's where this industry really is trying to push into it, and that's where you're going to find the latest and greatest things in automotive, is in the infotainment sections, as we notice. Those are going to be designed by the specific manufacturers of them.
Yeah. I'd say so. So there was LG Chem doing the boards on the battery, and then Hitachi doing the inverter, Lear doing the AC to DC, the power electronic boards, TDK doing the DC to DC converter. On these infotainment boards, there wasn't a manufacturer logo that you could identify. So we can't say definitively, but
then
you
they
can
all have to fit into a big general architecture of the vehicle, the electronic architecture, and how everything interfaces and communicates would be GM specific. So like we said, we got the TDK. It's going to be using the GM LAN system and communications. So there is some correlation there, but at the board level, it depends on where you're at in the vehicle, whose board it's going to be.
You can actually see style differences in the layout, too. So different companies do it different ways, and as you go down, they might leave more space for future adaptations or inclusions, right, or more test and debug access. And I mean, there are obviously different minds and different things at work in the different boards.
More questions? Yes, ma'am.
Okay, it's more of a comment than a question. I'm with Spansion.
Oh, you're in trouble.
And your question was about security, and
Right.
will they be able to get in there and hack it?
Right.
Well, there's many different security things that we could do at the Spansion level, so where you can't get in there, and there's different types of ways of securities that we put in there, so you're safe with us.
What you can say, and maybe you can provide some context here for us, is that
That's if you put it in. That's if you use the security features that we put in.
I think that comment's been on record now.
Okay.
But maybe you can help us out here. So we did, that was a Spansion part that we took the firmware from.
Yes.
Obviously, it was not difficult to get the firmware to that level. I don't know, maybe you can comment on what would happen if somebody took it there and started to want to take it to the next level instead of just looking at it. Can you comment on that?
Well, we work closely with the Tier 1s that put that there, and with QNX. and how they, and how you downloaded that and everything. I'd be very curious in how you did that and what they allowed you to do to a certain point. Mm-hmm. So, we work closely with them and how they can use the security things that we have. You could lock down sectors, page, everything, and what they would employ. Now, one of the things that, you brought up is, like maybe in the infotainment area, now you've got these downloadable apps that you could do and everything like that. So certain things, you may want to be able to write into those sectors, to make it for a better user experience or Pandora or whatever it is.
Did you see talk this morning by any chance?
No, I didn't, and I'm sorry.
Because he talked about it, and this is definitely not my area of expertise, but they managed on a vehicle, and I forget which one it was, but to get the tire pressure monitor to blink, and then he went on to say that you could go in there and start putting code, and this was from a remote. This wasn't plugging in. This was remotely, right? So you could get that, and then they were working on getting code loading on board, and apparently they've done that type of thing. So it's a very interesting area to me, that in a manufactured vehicle, production vehicle.
I'd like to know how did they use that based off the wheel sensors? Because typically you got to.
When they do the wheel,
the tire pressure sensors all have a specific ID that's fed back to the module, and you have to program them individually. And they actually do that on the line, and what they'll do is they'll offset it because you can only program one at a time, or you get the wrong wheel being shown on the display. One of the first vehicles I saw that I actually did a training course on, it was on the Prowler, and it didn't have a spare tire. Again, this one doesn't have a spare tire, so hence the low pressure tire sensor monitor. It does have a can of fix-a-flat in the back, but other than that, but they are programmed individually, so you could get in there. Do you break that RFID, or do you do it right to the module itself? Because it is a transceiver. It does transmit and receive.
They somehow managed to spoof the RF signal from the tire sensors and go in, and that I can kind of appreciate that you could do that, but then to go in and use that as an access point for the other firmware is quite interesting.
So when we started this program and we announced it publicly, one of the first direct messages I got on Twitter was from a guy in the hacker community, and he said, "When are we going to hack into the Vault?" And I said, "We'll talk." So stay tuned on that front. Any other questions? More questions? We have 2 minutes left. I'm going to ask you guys sort of a wrap-up question, because first of all, thank you. You've done a fantastic job, not only at the teardown that we did in Michigan, but over the last 3 days, and putting together some just amazing insight here. Do you have any sort of general takeaways on the overall design of this car, Because we all talk about how leading edge it is, this, that, and the other thing, but, I mean, you guys are the experts, Al. You've torn down 6 zillion cars.
I guess the biggest thing I found was interesting was the battery pack itself. There was this recent incident with Nishta. They did a side impact and the rollover and the crash and everything. But when we pulled the cover off that battery pack, we've never seen it before. I do these things blind. I mean, I did get the service manual, and I read through that 400 pages from one end to the other, read every documentation, and as I'm pulling that thing off, there's a little static electricity discharge. So it was like, man, give you a little uneasy feeling at the point. But just the amount of quality inspection checks. If you look at that battery pack, other than the red paint and the blue paint, well, actually it's fingernail polish where the coolant loops are, but you'll see little paint marks on every slice of the battery pack. A little green mark, that's a quality inspection mark. You look at the connectors, they have another paint dab on it. Basically, somebody puts it together, the next guy's looking, did you put it together? And they do that throughout the whole hybrid system on the components. You won't see it so much in the engine, but with the new technologies, I was really surprised how much inspection they really did, and trying to maintain that quality level that they're trying to achieve with it.
John, any final thoughts as we wrap up?
Sure. I'll just say that this is in agreement with what Al said, was that I think that electric vehicles are kind of cool to a certain person, and they're very scary to another type of person. And the whole business about the lithium-ion cells exploding in flames and burning and things like that, and people really get into that. So my sense of it was that they've had to really emphasize safety. The worst thing that could happen to a battery pack is an event like that. So the whole design is oriented towards extreme safety. Lithium-ion cells don't really explode and burst into flames, as I understand it. They really slowly burn in the worst case. So there isn't really that danger have to be careful what I say about this, because watch, but they're not an explosive type of material. So GM's really overemphasized and over-engineered on the side of safety. This is a 435-pound pack. Only a fraction of that is the actual lithium ion. The rest of it is the mechanicals, the electronics, the diagnostics, all the stuff that's designed to keep this thing really, really, really safe.
Because if you include that battery pack with all the other electronics, when we weighed them out, as we were doing the teardown, you might have seen a guy up in the screen in the left. It looked like he was watching the internet. Somebody said throughout the course. We actually mapped it into our software so we could capture the weights, the assembly times. We actually took 500 pounds, counting the battery pack, of electronics out of the vehicle when we disassembled it. We removed about 1,200, counting doors and that. But there is a lot of weight in just the electronics overall.
Mm-hmm. And the final thing I'd just say very quickly is just that if you come up and take a look at this after the talk, it's an interesting mechanical design. You'll see hose clamps connecting the modules, the coolant pipes on the modules, like real hose clamps that you would use on your hose at your cottage. So, you don't normally do that. And Al can speak to this when you're going to make 10 million of these things. I think it's 2011 they had sold 7,000.
Well, this was outsourced to a tier 1 supplier. If it was an OEM, they'd be using spring clamps, quick release. Just to reduce the assembly time.
So it's a design and evolution. It's going to be changing. They're changing the chemistry. They're changing the design. And we'll see what the future holds.
So in wrapping up, thanks again, guys. Just a fantastic job. If you were at all 3 of our teardowns, God bless you. If you weren't, we will be publishing this on Drive for Innovation in the coming weeks and months ahead. So you'll be able to see that there as well. And if you're concerned about your breath, we have some breath mints with the little car, and we also have a couple of USB sticks that we've been giving away. But I really want to give these guys a round of applause because they've done a phenomenal job. Thank you.
So we're supposed to bow now?